Section 4.1, Writing Equations in Slope-Intercept Form. Alright, so we're going to take a look at a little scenario here and see if we can use Slope-Intercept Form to figure out how to work with it. In 2000, the average cost for college tuition in the United States was about $14,000. In 2010, that had jumped to $18,000. Using a linear model, I'm going to be able to predict how much it will cost in 2033 when my daughter gets to college. Whew, that's a little overwhelming to think about, but let's see what we can do here. Well, I'm going to start by trying to write the information that I know. And it's kind of big to use numbers like 2000 and 2010 and 14,000, so I'm actually going to write these values a little bit of different ways. I'm going to identify my variables in a convenient manner. Instead of talking about the year 2000 and the year 2010 and the year 2033, I'm going to think about this as x being my number of years since 2000. That'll be a little bit more convenient. It'll kind of give me a little bit less larger numbers to write. And in terms of the y, which I'm going to have for my cost, that seems to be my output, my dependent variable, instead of dealing with 14,000, I'm going to talk about thousands of dollars. That'll make it easier to come up with some ordered pairs. Easier to write, smaller numbers to work with. So keeping that in mind, I want to identify my two ordered pairs. So I know in 2000, the cost of tuition was about $14,000. So how many years since 2000 was the year 2000? Kind of a silly question. It was 0 years later. And how many thousands of dollars did it cost? It cost $14,000. So that's one of my points. My next point is going to come from in the year 2010, trying to figure out that the cost had jumped to 18,000. So 2010 was how many years since 2000? That would be 10. And the cost was how many thousands of dollars? 18. That's the information that I know. Ultimately, I'm looking to predict how much it's going to cost in 2033, which is going to be 33 years after college. I don't know what that cost is yet. I hope it's not too much, but that's what I have to be looking at. That's ultimately what I'm looking for. All right, so let's see how I can do this now. Where do I start? So the first thing I can do is just graph those 2 points that I found, graph what I know. So I've created this coordinate grid, and I've graphed the points 0, 14, and 10, 18. You can see that I also have the labels of thousands of dollars and years since 2000 down at the bottom. And that's what I'm looking at here. So from this, what can I find? Well, I might realize that these 2 points are going to form a line. And I'm not going to draw that in yet. If I have a line, I've got two things that I can figure out. One thing I could figure out would be slope. And I know that slope comes from rise over run. So if I can figure out the slope by going up 1, 2, 3, 4 spots, and then going right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots, I can figure out that the slope of this line is going to be 4, which is the rise, over the run of 10. Now 4/10 is actually going to reduce to 2/5. And I don't want to make that 0.4 or anything like that. I want to keep it as that fraction. 2/5 is ultimately the rise that I'm looking at here. The rise over run, excuse me. So in addition to finding the slope, remember this section's about slope-intercept form, I can find my y-intercept. And that just comes from looking at the graph and seeing that it's right here. It's where my x value is 0. It's whatever my y value is. So this right here is going to tell me that b equals 14. And so now if I have the m and I have the 14, I actually can write the equation of the whole line. Since I know slope-intercept form is y equals mx plus b, I'm just going to write this as y equals 2/5 x plus 14. And that right there is the equation of the line that would connect these 2 points. All right, well, now that I've got that, let's take a look at the line. You can see I've got the equation here, y equals 2/5 x plus 14. Use a nice little ruler, connect that, and just want to see if I can use this. Well, I got to remember what I'm looking for. Ultimately, I'm looking to figure out what the cost of college is going to be 33 years after the year 2000. And so what I'm doing is I'm looking at an x value of 33. And an x value of 33 is going to hit the graph right around here. Now, unfortunately, that's not on a nice clear point. If we actually zoom in there, maybe we can see what's happening here. The 33 is right around this point right here. So definitely not a real clear indication of what we're looking at. That means there's something else that I'm going to have to do. I'm going to have to just use the equation of the line. But that's fine because I have an x value. So all I can do here is plug in and solve. So I'll say y equals 2/5 times 33, that's my x value, plus 14. I'm going to do 2/5 times 33, and it's going to give me a decimal. I'm just going to leave it as a decimal in this case. 13.2 plus 14, and add that those two numbers together. I'm going to get, should have my y there, y equals 27.2. And so that's the answer that I get. Y is 27.2. All right, but what does that mean? Well, since the point 33, 27.2 is actually on the line, that's actually telling me all the information I need to know. This x value of 33 is telling me 33 years since 2000, which is 2033, the year we were wondering about. It's going to cost $27.2 thousand on average for tuition at college. So 27.2 thousand, I got to think about what that means. So when I multiply 27.2 by 1,000, it shows me that in the year 2033, average college tuition will be $27,200. Now, this is not a guarantee. This is an approximation based on a linear relationship, but based on the data that we have, it's kind of the best that we can do. So from using the original information, we actually created an equation in slope-intercept form and then used it. So that's pretty good. What's not so good is that that's a lot of money that we're going to be shelling out for Miranda to go to school. That's expensive. All right, so let's just talk about a couple of the alternative approaches we could have taken here. Our ultimate goal was to determine the slope and the y-intercept. It was pretty clear what our y-intercept was since that was our starting point. The 0 for the x in the number of years since 2000 made that easy to find. But instead of using rise over run, we could have used the slope formula with our 2 points. Our slope formula, which is y2 minus y1 over x2 minus x1. If I plug in the values that I have there, you'll see that that would be 18 minus 14 over 10 minus 0, which is 4 over 10, which reduces to the 2/5, the same thing that I had before. So that's one of the options that I could have. The other thing that we could have done is we could have used function notation. I could have written, instead of the point 0, 14, I could have said this is going to be a function and call it f of 0 equals 14. And instead of the point 10, 18, could have called that f of 10 equals 18. That changes our equation from y equals mx plus b to f of x equals mx plus b. Specifically, f of x equals 2/5 x plus 14. Then we're looking to find f of 33. We'd go through that just the same way as we did before. We'd do the 2/5 times 33 plus 14. And we know that ultimately, that leads to 13.2 plus 14, which is 27.2. So f of 33 is 27.2. We could end there. All right, so just a couple of different approaches you could have taken, but ultimately it leads to the same point. So just a quick summary here. First thing you need to do is determine slope. use either rise over run or the slope formula, or sometimes you'll even be told what slope is. Then you have to identify the y-intercept. Remember, that's when you're crossing the y-axis. That's when x equals 0. Sometimes you'll get that from the graph. Sometimes you'll be given a point. Sometimes you'll be told b. You're going to fill those values into the slope-intercept form for m and b, and then if there's any other remaining questions, answer them. Plug in for x, plug in for y, do whatever you need to do. All right, hope that this makes a lot of sense.